launch of Endeavour.
After a successful launch on May 16, 2011, the Alpha Magnetic Spectrometer AMS has been taking data since its installation on the International Space Station.
And thank you very much for the great ride and safe delivery of AMS to the station. Your support and fantastic work has taken us one step closer to realizing the science potential of AMS.
AMS has accomplished the first phase of its life, which means the deployment on the International Space Station, which took place on the 19th of May of 2011 of this year. And it's the first step, and immediately after the installation, it started to gather a huge amount of particles, the cosmic ray particles at various energies. Is an uninterruptible flow, 24-hour days, continuous. It's not like an accelerator where we have machine development. The universe is providing cosmic rays all the time.
After an initial period at the Johnson Space Center, NASA's mission control facility based in Houston, Texas, the entire AMS team moved to CERN on June 23rd. To mark the occasion, NASA's administrator, Charles Bolden, visited the AMS team at their new facility. The AMS team is now at home in the newly built Payload Operations and Control Center of AMS, or POC, from where the detector is controlled and the data acquisition is carried out.
So we are now in almost 3 months of data taking, and we are still in the phase of finalize the calibrations of some sub-detectors. So the data are interesting because we see that the detectors are responding as we were expecting in terms of noise level, performances. But we still have to finalize the settings of the whole detectors before we can start the so-called physics run, where you can see clean signal.
We do have, of course, plenty of high-energy events. The Cosmos is a fantastic accelerator. It's providing us, for the first time, we can detect positron and electrons in several hundreds to TeV energy range. Those energies for single particles, for single lepton, are very high, even if compared to LHC. We are now calibrating the detector to the last bit of detail, because the effect we are looking for, antimatter, dark matter, require a complete understanding of the data. So the calibration now is the main goal of the various sub-detectors of the experiment.
AMS is special because it's being operating on the International Space Station. So we cannot have access, mechanical access to the detector. And it's not foreseen that astronauts intervene directly on the detector. So, for instance, if we have to send commands to the detector, we have to wait to have a band availability so we can talk with the station. And this information we get from NASA people, and they also need to give us the permission to command.
AMS will continue taking data for the entire lifetime of the International Space Station. Even after takeoff, close collaboration with NASA continues to be crucial for the future life of the detector.
Thank you very much. It's very kind of you. Thank you very much. Okay? It's an honor to work with you. Thank you.
AMS has embarked on a mission that will shine a light on the dark side of the universe.